Now with inheritance, we're going to show an example. We're going to be working with this example. Animal may have a set of methods. So this is a class that can create, quote, animal objects, and it might have a set of methods. And then reptile isn't going to inherit from animal, and these are what these arrows represent. So this is another type of diagram which represents an inheritance hierarchy, where you have several classes, in this case 4, and they're all related to each other by the is-a relationship, specifically where the arrows go. So reptile is an animal, mammal is an animal, and dog is a mammal. Dog is not a reptile. Now you would say, well, of course dog's not a reptile, because I've learned in biology that that's not the case. But in programming, even though we're representing that relationship, inheritance has a very specific meaning. It means that the methods in animal, reptile has all the same methods, and in fact it has it because it's inherited those methods from animal. Dog does not inherit any methods from reptile, so any unique methods in reptile don't show up necessarily in dog. They're not guaranteed to be there. But if you inherited, like mammal inherits from animal, mammal is guaranteed to have the same methods that were in animal. And if mammal has new methods, which would be added to animal to make a mammal, then when you do dog, you could add more methods. So as you go down this chain of hierarchy, things get more specific, and as you go up, they get more abstract. And that's generally true when you look at inheritance. And just a note here, the way IPython works is you can put some code here to display a file. So this is actually going out and getting a file and displaying this picture. So that's how you display pictures in IPython. So here's a really simple way of showing inheritance. I haven't listed any of the methods. So this sets up real inheritance by this diagram, but doesn't have any methods. So first we create a class called animal, and we pass to indicate it doesn't do anything. There's no methods or data. And then we have a class mammal, and indicate that this inherits from another class, you put in parentheses the class it inherits from. So this is declaring a new class called mammal that inherits from animal. Reptile inherits from animal, and dog inherits from mammal. So here are some facts about this. Mammal is an animal, and you can tell that by looking at this or the diagram we started with. Reptile is an animal. Dog is a mammal. Dog is also an animal. So we'll see that if you can fall anywhere up this chain, you have that is a relationship. So dog is an animal because it's derived by inheritance from animal, in this case indirectly through mammal. Reptile is not a mammal or a dog. So reptile, there's no chain that goes up to get through mammal or dog. So it is not one of those. And an animal is not a reptile or any other subclass. So that's another term. These classes here that inherit from the one above it, there's several terminology. This is called the base class when you talk about two classes like reptile and animal, and reptile is called the subclass. So now I'm going to add methods. So you'll see here I have class animal, and we have a constructor, and we have a piece of data. So the piece of data, every animal will have a name. Okay, and then we have a method called speak, get name, and represent things as a string or internal representation. So it just returns name, self-name. Now you'll see here, speak says I am animal. So it has a specific action. And then we define mammal. This is how you have to do your constructor. So because this inherits from another class, you're required to have a constructor call to the other class. So what happens is when it makes a new mammal, it comes into this initialization, and it's passed a couple parameters, so you're defining that. the first thing you have to do is you have to initialize the superclass because this is inheriting from it. So the way you do that, you say super, parentheses, period, and then you call its initialization routine this way, and then you pass any parameters it requires. And it requires, if you look up here, it requires a name. So it's going to set the name. So I call that, and I'm passing basically the name that was passed to this initializer is now passed to the super constructor. Because the animal is the one that keeps track of the name, and mammal actually is going to have another data property that it's going to add, which is the color, which animals don't have. So it now sets the color for its own property. And then we have a get color to get that property. So we have a method to return that property. And then we have a method to represent this as a string. And let me just mention something. This is dynamic. So the underscore string does self.getName and self.getColor and composes a string and returns it. But you notice we haven't redefined the REPR, and that's because in the original REPR up here, it calls string. But if it's an animal, it calls this string. But in the new class that inherited from animal, it's defining string again. So which one does it pick? And it uses a very important rule. If in a subclass you define a method that's already defined for the superclass, it overrides it. So this definition for string replaces this definition. So when you actually call string for this class, it calls this, and when you call REPL for this class, it's not defined for mammal. So what happens is it says, well, it is defined for animal. So it goes up here and it calls REPL for animal. And then this says call self string. Well, it's actually the object it called it on is not an animal, it's a mammal, so it's going to jump back down and call this new string. So it dynamically picks what's the current string for the object type you have. So that's an important concept. So here it tests it out. It creates an animal and a mammal. And the mammal has a color red, Mr. Fox, and then it prints both of these. And you can see when you print the C2, prints Mr. Fox is red, so it behaves a little differently. So let's add reptile and dog. So to the code above, we're going to add reptile. And you'll see it has, instead of color, it has scales. So it has a name and it has scales, which is the number of scales. So just like the other subclass, whenever you do a subclass, you have to call the super to initialize the superclass. So that, and we pass it the name. And notice, let's see, it redefines string, and it defines a new method that only reptiles have called slither. And when you call slither for a reptile, it prints out the sound of slithering. Okay. And then we define dog as a mammal. And you'll see dog, we have a food property. So it's unique to dogs have a food property, which is the kind of food. And this is another way of initializing a super constructor. You can do it either way. So you can, instead of saying super parentheses, you can say the actual name of the superclass dot init, and this will do the same thing. So this also redefines speak, and you'll see reptile didn't redefine speak, and mammal didn't redefine speak. But we have dogs now can speak. Let's see, could animals speak? Let's see, animal could speak. It says I am animal. So the one question you might think about is if you ask a mammal to speak, what does it do? Now if we ask a dog to speak, it's going to say arf arf. So we've redefined it or overrid the original speak that's in mammal. Okay. And then we have another method called getFood, which is going to return the food. So here we have a little, we created a reptile and a dog. And you notice a dog, we pass it brown. Milkbone, and Fido. And that's because the superconstructor of dog is a mammal, and mammals have a color, so we have to get the color. And I'm going to point out one more thing. The string here uses the fact that there's a string for mammal, so it actually calls mammal.string to get the string for a mammal, which is going to give the color and the name, and then it appends the food attribute that is just for dogs, so it makes a new string. So this, if you're going to use a method that you're redefining, we're redefining string, if we didn't put this mammal dot here, it would just call itself. So this specifically calls string that belongs to mammal rather than string that belongs to dog. So here's a new class diagram that shows you these methods and the properties. So you can see animal has name, and when we define mammal we add color. So mammal actually has name and color and speak because it inherits these two things. Reptile adds scales, so reptile actually has name and scales, and has speak and this new property, this new method slitter. And then dog inherits from mammal, so it's going to have food, color, and name, and it redefines speak. And so there's the thing. So here's some definitions. Superclass is the class that you're inheriting from. Subclass is a class you're creating that's extending a superclass. Superclass is synonymous with super, parent, or base class. So as if you look at other books on object-oriented programming and languages, they use these terms kind of interchangeably. Subclass synonyms are sub, child, extended class. And the term override is to redefine a method by the same name that's in the superclass. And we'll do another video on inheritance and composition. And then we'll talk about polymorphism. And those are subjects that are not in the book.